Very good morning, my dear friends. A hearty welcome to my channel, Mechanical Engineering Lecture Series, and myself, Dr.M.H.Annaiah, Vice Principal at Saptagiri College of Engineering, Bangalore, and former professor at M.S. Ramaiah Institute of Technology, Bangalore. Friends, in today's session, the problem on the projection of lines runs like this. A line AB measuring 90 mm has its end A 20 mm from both HP and VP. Very obviously, this is the problem in the first quadrant. The line is inclined at 40 degrees to HP and 50 degrees to VP. Draw its projection, means you have to draw the front and top views of the line AB, which has got a length of so much. So let us commence this problem with the collection of this data, that is given in the question. He says there is a line AB having 90 mm, that means the true length of the line TL is represented by A dash B1 dash, which is also equal to AB1, which is given to be equal to 90 mm, that is 90. Has its end A. There are two ends for the line A and B. One of the ends A, that A is at a distance of 20 mm from both HP and VP. So 20 mm above HP and 20 mm in front of VP. Along with this, he has given what is the angle made by the line with HP and VP. The angle made by the line with HP is 40 degree. So we represent that as theta, the angle made by the line with the HP, and it is given to be equal to 40 degrees. Similarly, the angle made by the line with the VP is phi, and it is given to be equal to 50 degrees. This is a special case of problem where the angle made by the line with HP and VP is becoming equal to 90, that is 40 plus 50 is equal to 90 degrees. So we will see the result at the end of this session. Friends, let us start the problem by drawing the XY line, the line of intersection of VP and HP, and mark VP and HP to indicate first angle projection. We have marked this. Let's start this solution by locating this end A. The end A of the line is 20 mm from both HP and VP. Friends, I just mark a point here and another point on the other end. This is an end projector. These are having a distance of 20 mm. So the end A, the front view is A dash, 20 mm above, and here this is A, that is also 20 mm from VP. So we have got one of the end projectors of that line AB, that is A, at a distance of 20 mm from both HP and VP. So this data is over. Next point he says, the line is inclined at an angle of 40 degrees to HP. So through this point A dash, I can just draw a line here of length is equal to 90 mm. TL is equal to 90 mm. Mark this as B1 dash, the true length of the line, and this line drawn here is drawn at an angle of theta equal to 40 degrees, 40 degrees. So we have marked the true length of the line, the locus of that B, locus of B, the end B. Locus of B we have marked. Friends, on the same line, let us draw the true length in the top view. So here we have the end A, the true length is AB1. So how to draw that? So here that angle is given to us. The angle is 50 degree. So from the point A, I am going to mark a line here, a straight line of length is equal to 50 mm, and mark the locus. Again this becomes the locus of B in the top view, and this length is equal to the line what I have drawn is of length, I will say true length equal to 90, and this angle the line is making with the VP is 5, that is given to be equal to 50 degrees. So once you know the length and the angle given, you can just mark it. Friends, I have used all the data given in the question. Everything is exhausted. Now friends, let us see how to get the projections of this line. It is very obvious. Whenever the true length are given, you can just draw a vertical line from this end B1 dash till here, the locus of the end A. So I will draw a line from there till it cuts the locus of A here. I call that point as 1. Friends, so now with A as center and A1 as radius, A as center, A1 distance as radius, I am going to strike an arc. So friend, this arc, whatever you draw, is going to meet or cut this locus here. This end is B1 and this point is going to be B. Friends, if you join A and B, this is going to be the top view of the line. Top view is AB. I will simply mark it as top view of the line. Friends, similarly, you have this true length here. You can write a vertical line, another vertical line from this till the locus of this. So from here I am writing a line here with this, we will call this point as point 2 with center A dash, radius equal to this much. You draw an arc to cut the locus. So I will extend this locus here. That locus is extended here. Now with this center and this distance as radius, if you strike an arc, here, friends, it is going to come and meet here. This is the arc. When you draw, it is going to meet here. Join this point. This is going to be your B dash, and if you join this, this becomes the front view of the line. This is the front view of the line. A dash, B dash. AB is the top view of the line, TV, and this will give you the complete projections of the line. Friends, you may ask me, what is the distance between the end projector? Friends, you can see the end projector AB and the end projector A dash, B dash, they are on the same line. So in this particular problem, DEP is equal to 0. That is one part you should know. And secondly, you can also observe here, in the previous problems, the front and top views never lie or just fall on the same line. But here you can see, whenever the sum of this angle, that is theta plus phi, is equal to a right angle, that is 90 degree. Because here you got this 40 degree, the other one is 50 degree, the total becomes equal to 90 degree. When this is the case, then the front view and top view, they fall on the same line and the distance between the end projectors is 0. This could have any combination like 30 plus 60, 45 plus 45 and so on. So whenever the angle made, the sum of the angle made by the line with HP and VP, that is theta plus phi, is equal to a right angle, that is 90 degree, both the front view and top view, they fall on the same line, and DEP, distance between the end projectors of the line measured parallel to the line of intersection of HP and VP, becomes 0. Friends, I hope you have followed the problem and the corresponding solution. This is a special case of a problem. And friends, if you have followed this problem and are happy with the presentation made by me, please subscribe without fail, and this subscription costs you nothing. Please share the information with all your friends. Thank you very much for watching my YouTube video. Have a wonderful day. This is Dr. M.H. Annaiah signing off.